The rumor stating that AEP is requiring a disconnect before the meter for 480-volt three-phase services is false. AEP is not implementing such a requirement. Disconnects are crucial components in electrical systems, ensuring safety and facilitating maintenance. Understanding the requirements for disconnects in different voltage systems is essential for electrical contractors and engineers. In electrical systems, a disconnect switch serves to isolate a circuit or a piece of equipment from the power source. This isolation is necessary for performing maintenance repairs or in emergency situations. Disconnects provide a visible break in the circuit, confirming that the power is indeed off. National and local electrical codes dictate the specific requirements for disconnects based on voltage, amperage, and application. For instance, the National Electrical Code, known as NEC, outlines requirements for disconnects in Article 430 pertaining to motors, motor circuits, and controllers. Article 440 covers similar requirements for air conditioning and refrigeration equipment. A 480-volt three-phase service is a common type of electrical service used in commercial and industrial buildings. This service provides power at 480 volts, with 3 separate phases of alternating current. The high voltage level allows for efficient power distribution over longer distances. Typically, a 480-volt three-phase service involves a main disconnect switch that can energize the entire service. This main disconnect is usually located near the point where the service enters the building. Branch circuits within the building are then fed from this main service through distribution panels. Each branch circuit also requires its own disconnect switch to allow for localized maintenance and repairs. The NEC specifies the requirements for these disconnects, including their rating, location, and accessibility. Grounding is a critical aspect of electrical safety. Grounding ensures that any fault current will flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. The NEC provides detailed requirements for grounding in Article 250. A properly grounded system provides a low impedance path for fault current, which minimizes the risk of electric shock. Grounding electrodes, such as ground rods or metal water pipes, are used to connect the electrical system to the earth. The size and type of grounding electrode are determined by the size of the service and the type of building. Bonding is another important aspect of electrical safety. Bonding involves connecting all non-current carrying metal parts of the electrical system together. This includes metal conduits, enclosures, and equipment frames. Bonding ensures that all metal parts are at the same potential, which reduces the risk of electric shock. The NEC requires that bonding conductors be sized appropriately for the size of the circuit. Overcurrent protection is provided by circuit breakers and fuses. These devices are designed to interrupt the flow of current if it exceeds a certain level. Circuit breakers can be reset after they trip, while fuses must be replaced. The NEC specifies the requirements for overcurrent protection in Article 240. The size of the circuit breaker or fuse must be matched to the ampacity of the conductors in the circuit. Proper labeling is essential for electrical safety. All disconnect switches, circuit breakers, and other electrical equipment must be clearly labeled to indicate their function. Labels should be durable and easy to read. The NEC requires that all electrical equipment be labeled with its voltage, amperage, and other relevant information. Electrical inspections are conducted to ensure that electrical installations comply with the NEC and local codes. Inspections are typically performed by qualified electrical inspectors who are employed by the local government. Electrical contractors are responsible for ensuring that their work meets the requirements of the electrical codes. Electrical safety is paramount. Working with electricity can be dangerous, and it is essential to follow all safety precautions. Always energize circuits before working on them. Use properly insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to work on electrical equipment, hire a licensed electrical contractor. Electrical systems are designed to provide a safe and reliable source of power. By following the NEC and local codes, electrical contractors can ensure that their installations meet the highest standards of safety. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important for electrical contractors to stay up to date on the latest code requirements. Continuing education courses are available to help electrical contractors maintain their knowledge and skills. The proper installation and maintenance of disconnects are critical for the safe and reliable operation of electrical systems. Always follow the NEC and local codes when working on electrical equipment.